Alright, in this problem we have a 1-foot cube that's cut into 4 pieces by 3 cuts that are all parallel to the top of the top face of the cube. The first cut, let me scroll down here and so you can see the picture here. So the first cut is a 1/2 foot below the top. And then the second cut is a 1/3 of a foot below the first cut, and then the third cut is 1/17 of a foot below the second cut. Okay, and these are all labeled A, B, C, and D. And then, okay, so they're taken apart, and the pieces are lined up like this. Okay, like it's shown here. So C, which is the 1/17 of a foot thick piece, is here, and then B's a 1/3 of a foot in thickness, A is a 1/2 foot in thickness, and then D is the leftover, gets stuck over here, and they're all glued together. And the question asks, what's the surface area of this new solid? Okay, the new solid being this stair-step like thing. Okay, so well, let's just look at each face of this solid. Now if we were to look down from the top, what we would see is a square foot here, a square foot here, a square foot here, and a square foot here. So we'd see a total of 4 square feet, right? So the top is 4 square feet. Alright, if we look up from the bottom, we'd see something similar. It would just be 4 square feet. 4 feet squared. Alright, it's supposed to be a 4. And alright, now let's look at the side. Let's looking at this side here. Now you can see we just have all these strips, but you know they're the same strips that we saw over here. Alright? And here we saw 1 square foot, so if we look at it from either the right or left hand side, we'll see a square foot. So I'm going to write sides. I'm going to combine them both together. So whether we look at the right side or the left side, we see 1 square foot. So we see a total of 2 square feet. Okay? And then finally, let's look at it end on. Alright, so let's either look at it coming this way or up looking this way. Alright? So we're going to see these surfaces here, 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 and here. Okay? Well, the tallest one is a 1/2 a square foot, right? This is one half, all right, from top to bottom. Okay, so you know, even though part of this 1/2 a foot of block A is blocked by block B, okay, and then part of that is blocked by part C. But if you look at it as a total, you're going to see this and this and this, but it's going to add up to a 1/2 a foot because that's the maximum height. Okay, so I'm going to write ends. Okay, so we're going to see a 1/2 a foot looking this way. We're also going to see a 1/2 a foot if we look at it from this end, right? We're going to see this leftover bit, and then we're going to see this half a foot block. But the sum, if we look at it from that end, is going to be 1/2 a foot. So the ends, we're going to have 1/2 a foot plus 1/2 a foot, so we're going to end up with 1 square foot. Okay? That's the easy way to do the problem. We can just add that all up then, and we get 11 square feet. Okay? And that's the answer. Okay? I know when I did this problem the first time, I didn't think of the simplest answer, or the simplest way to do it first. For some reason I was thinking I needed to know what this leftover bit, how thick that was, but then, you know, so I went through a lot of work for nothing, and all you need to do is look at it as a top view, a bottom view, a side view, and an end view, and just look at what's the area that you're going to see, the total area. And don't worry about the individual thicknesses. The only really matters, at least for the end views, is just the you know, the tallest one, right? You're going to see everything. You're going to see everything from the bottom up to the 1/2 a foot. So you're going to see 1/2 a square foot because the length here is still a foot. So it's so anyway, so there you go, 11 square feet.